Hey guys, this is how to do math to math stoichiometry, Snoop Dogg style. So first of all, back to this diagram here. What I mean by mass to mass is we're going to be starting off with mass of compound A, whatever we decide compound A is, and we're going to need to get all the way to mass of compound B, whatever B is, okay? So notice that I can't go directly from there to there. The only path that I can take is through the moles and on up to grams. So this is going to be the first time that you're using more than one step, okay? So we're going to work through a couple practice problems. So here is one I set up. So how many grams of iron are needed to make 50 grams of iron oxide? I already did balance that equation for you because that's not really what we need to spend time on. So we're going to find what we have and what we want. Remember, those are always our first steps. So 50 grams of Fe2O3 is what we have, and grams of Fe is what we want. So those are going to be our first two bits of information. So 50 grams of Fe2O3 goes in our first box. And then way on the side, and I might be even writing too big, we want grams of Fe. That's what we want to end up with. So I might need to start writing smaller. All right. Oh, that's okay. Now we want to drop it like it's hot. Snoop Dogg says, drop it like it's hot. Notice that I did not automatically drop any numbers. I just dropped the units like it's hot. Okay. Now at this point, I look at my stoichiometry. Here I am in grams of A. Whatever is my first compound, we're just calling it A. Okay. I want to get all the way to grams of B, grams of something different. Okay. So I want to go from here to here. I've got to go to moles first. It's my only choice. It's the only thing that grams connects to. So that means that on top is going to be moles of Fe2O3 because it's the only thing those grams connect to. Okay. Okay, so again, here we are at grams. We have to go to moles because it's the only place we can go to. So following that arrow along, I see that it tells me there's 1 mole in this case. So that is why I plug the 1 in there. Okay, that's the only reason. My molar mass, I have a little note. I got to go to the periodic table. That means I need to look up the values for Fe2O3. So using our periodic table, we look up iron, 55.85. But remember, there's 2 of them, okay? And oxygen, 16.00. But remember, there's 3 of them. So when you add all this up together, you're going to get 159.70 grams per mole. So that part goes with the grams, 159.70 grams per our 1 mole. Now, Snoop Dogg lets us cross off the units. So we cross off grams and grams. And I'm at moles of Fe2O3. Don't stop here. This is why we write this down over here. Did I get to what I wanted? No, I did not. Because I did not get to what I wanted, I need to drop it like it's hot again. Okay? Now my units right here are dropped like it's hot. Okay? So I didn't get what I wanted. I kept going. I dropped those units like it's hot. So here I am in moles of Fe2O3. I went from grams of Fe2O3 to moles of Fe2O3. I could go to particles of Fe2O3, but that's not what I want. Or I can go to moles of a different compound. This is a different compound. So I've got to go here first before I can go here. So I'm going to go here. So if I have moles of Fe2O3, moles of my A on the bottom, I'm going to put moles of my Fe, which is moles of my B, on top. Now, where do I get this from? My balanced equation. Good thing it's already balanced for me. So I look at my balanced equation and I steal my numbers. This 2 comes right here. Moles of Fe, this 4 comes right here. Sorry. So there you are. The 2 came right there because it's for Fe2O3. The 4 came right there because it's for the moles of Fe. Snoop Dogg lets me cross off my units again. Did I get to the units I wanted to yet? No, I didn't. I didn't get to where I wanted to, so I'm going to keep going. So you can see I ran out of room here, so I'm going to move my grams of Fe just over here. Okay, because I need room to drop it like it's hot. Okay, moles of Fe. All right, so here we are. We went from grams of iron oxide to moles of iron oxide, and then moles of iron oxide to moles of iron. We want to get to grams of iron. There's our grams, so this is the direction we're going. Looking at our arrow here, it tells us there's 1 mole. That is why I plug in the 1 mole. That is the only reason I plug in the 1 mole, okay? That's because it's told to me right here. And then it says molar mass on top. If you don't remember that molar mass means grams, by all means, write it in. That means I need grams of that thing, in this case, iron, on top. Going back over to my periodic table, 55.85 is my grams for iron. Sorry, it's a little bit light. All right, so now we've got it all set up. Let's double check our units. Those cancel. I've got 1 on top, 1 on bottom. I'm left with grams of iron. Guess what? That's what I'm looking for. I finally got there. So again, I started off with grams right here. The only thing I can go to is moles. Grams of iron oxide, moles of iron oxide. Then to get to something new, to get to B, I got to go through the moles. So moles of iron, from iron oxide to iron, and then on to grams of iron. Everything canceled out in terms of our units, and we got to the units that we wanted to get to. So now we solve. It's just multiple steps, but it's the same steps. Let me turn it sideways a little bit. This is still multiplication across. I actually find it easiest to kind of multiply everything across on top and get all your top answers, and then multiply the things on bottom as well and get your bottom answers, and then divide by the top by the bottom. When you are all said and done with this, you will have done this right if you were able to get 34.97 grams of Fe. So again, and you can do this. There's no like specific way you have to do. Some people like to do this times this divided by this times this divided by this times this divided by that. That's fine if you want to do it. But some people feel like the less division, the less mess ups they have. So this times this times this times this. And they write that down over here. And then this times this times this. They write that down over here. And then this divided by this. Either one should get you that answer. All right. I know these are long, but I am going to do another one because I do think that they are helpful. So how many grams of water are produced when using 900 grams of oxygen? So again, finding what I have and what I want. We always start, I'm going to try to write a little bit smaller. We always start with what we have there. And then we move on to what we want. In this case, grams of water way on the other side. Grams of water. Hopefully I gave myself enough room there. And then drop it like it's hot, Snoop Dogg style. All right. So we grab our periodic table. Actually, we shouldn't do that yet. So here I am. I'm at grams of my first thing. I want to get all the way over to grams of another thing. So again, I'm going to have to follow that pathway. Grams to moles, then moles to moles, then moles to grams. I dropped my grams like it's hot. So I look at my choices there, or I follow the arrows. Grams from the periodic table should be on bottom. And 1 mole of that thing, oxygen in this case, is on top. So we're going to go ahead and get our grams. 16.02 for oxygen, but there are 2 of them. So that means I really have 32.00. All right, Snoop Dogg's going to let me cancel some units here. Grams and grams go away. Did I get to the units that I wanted? No, I did not. So I'm going to keep going. I'm going to drop it like it's hot again. What do I drop? My units. Whatever units aren't crossed out are what goes there. Okay, so moles O2. Here I am, right here. I want to go to a different element. You can also just kind of look at which pathway ahead of time. I know I have to go over here because I said I wanted to follow this way. So moles of oxygen is my A. I want to go to moles of something else. In this case, I want moles of water because I want to go to grams of water. So moles of water on top. Where do I get those numbers from? Of course, the periodic table. Moles of O2 is right here, so I'm going to bring that down. And moles of H2O is right here. I'm going to bring that over here. All right, let's Snoop Dogg check it out. Did I get to the units I wanted to get to? I did not. I want grams and I'm at moles. We're getting closer, or at least at the H2O. But Snoop Dogg says I got to keep dropping it like it's hot. So I dropped my moles of H2O. I'm right here. One last step to get to grams. I'm following this arrow here. It tells me I have 1 mole on the bottom. Perfect. And it also tells me I need the molar mass, grams, of water, because I'm still at B, okay? I'm at B now, I stick to B. Grams of water. So just a quick little oxygen is 16.0. Hydrogen is 101, but there's 2 of them, so that's going to give us 18.02 grams. Let's Snoop Dogg cross out. Units I cancel. I'm left with grams of H2O, and that is exactly what I want. Awesome sauce. I'm ready to solve. Okay, so same steps as before. Again, you can do this however you like. I tend to think it's if you're not great with calculators, do the top and then do the bottom. So 900 times 1 times 2 times 18.02, and then just write that total over here. And then 32 times 3 times 1, and write that total over here. Or you can do it 900 times 1 divided by 32 times 2 divided by 3 times 18.02 divided by 1, if you know how to do that correctly in the calculator. And your answer, if you do this correctly, should be 337.88 grams of H2O. So you can always go back and check your work, make sure you put it in the calculator correctly. Hopefully that helps you with math to math.